Hi everyone, I am Manoj from EC department second year. So I am going to present a topic about control system engineering, advanced driver assistance system ADAS. ADAS, advanced driver assistance system, is a technology that enhances the vehicle safety and it is useful and convenient by assisting drivers in various tasks. So it helps in accident prevention, lane keeping and automatic braking. So according to data, 95% of the accidents are caused by human error. So this ADAS system will help to prevent the accident. And the next thing is lane keeping. So we can see a white lane in the right side or left side of the road. So this sensors in the vehicle will predict the white line. So it will keep the lane as in the center and the automated braking. So it is the key component in modern vehicles. So actually data says that for the past year the market value of ADAS is 33.5 billion. So it is expected to reach about 83.6 billion by 2032. So this is the evolution of ADAS. So it started in 1980s and till now. So in 1980s there is a basic driver assistance. In that we used an anti-lock braking system ABS and electronic stability control under cruise control. So this is the first driver manually drive the car where he not have the enough specifications to drive. So second is the semiconductor, first semi-autonomous features. So here we used sensors, parking sensors and the traction control system. So in the early 2000s we used AI power, though at that time the AI comes into the picture. So we used lane departure warning, blind spot monitoring and adaptive cruise control. And 2010 advanced AI and connectivity. So we basically used sensors in 2000. Then the advancement of the 2000 is 2010, the automatic emergency braking, traffic sign recognition and vehicle to vehicle communication. In future we used to have level 4 and level 5 self-driving cars, AI powered real-time and decision making. So this level 4 and level 5 will be explained in the next slide. So this is the key components of ADAS. So ADAS have sensors, radar and LiDAR sensor, ultrasonic sensors and a camera. So basically these sensors will collect the data from the environment and convert it into a real-time data. Cameras identify the road sign. So this camera will identify the road sign, lane markings, traffic signal and pedestrians. So radar will use the radio waves where the speed and distance of the nearby vehicles will be clean even in a poor visibility. So after that LiDAR, lane detection and ranging system. So this creates a 3D map. This creates a 3D map of the surroundings, helps in the self-driving technology. After that we use the ultrasonic sensor. So ultrasonic sensor basically senses the range between the two objects. It uses the ultrasonic waves. It will find the objects and blind spots. So it basically uses sensors, a processing unit and the actuators. So the processing unit will collect the data from the sensor and it will process and gives output. So actuators engages in the actions such as braking, steering and acceleration. So in case of braking, if an obstacle is detected, it will use the braking system. So steering is used for lane keeping. As I said in the earlier, the white lines in the left and right side of the road will detect, these sensors will detect that line. So according to that the steering will be operated. Acceleration is adaptive in adaptive cruise control. So this is the camera, here range detection radar and ultrasonic sensor. There are more key components and will be explained in later. So this is the block diagram of the ADAS. So here is a transient protection. So what is a transient protection? If there is a voltage spike, the transient protection will be used on the reverse battery. If there is a battery, there is no battery usage, the reverse battery protection will come into the picture. Next is this supervisor. This control unit, this entire unit is supervised by this supervisor. So here the input is normal operation. The normal input is 6 volt to 18 volt. The full range volt is 3 volt to 35 volt. Hold rank can drop to 3 volt and the start and stop can drop to 4 volt. Load dump can spike to So after that, this unit will send the data to the ADAS processor. This is the main processing unit. So here we have 3 pins: B core, input output pins, analog pins, and the B3 V2 pins. So it will this will give the input to the ADAS processor. After that, ISP, it is a image signal processing. So if it gives input in a data form, which is if the camera will detect the input and send it to the ADAS processor. After that, image signal processing will detect it. According to that, the lane keep changing braking system works. So as I said earlier, there are totally 6 levels of ADAS system: 0th level, 1st level, 2nd level, 3rd, 4th, and 5th. So as I said earlier, 0th level it needs a driver to drive the car manually. So constant monitoring should be done in terms of riding. Next, the vehicle can operate steering or acceleration, deceleration in specific use. And then the 2nd level, the vehicle can operate steering and acceleration. 3rd level, vehicle can operate steering and acceleration specifically used in cases. The system can recognize its limits, alert the driver and maintain control unit until its driver take over. 4th unit, no driver needed. 5th level, no driver. As I already said, level 4 and level 5 doesn't need a driver. How ADAS works? So basically, this is the surrounding view. From this surrounding view, the sensors will collect the input and give it to the processing unit. The processing unit will collect the input, and according to that, the car will automatically drive. So first, the processing decision making. AI model analyzes the data and predict the potential hazards. Action and execution. Actuators control the brakes and steering and acceleration for the safe driving. Driver feedback. Alerts and assistance features inform the driver about the road conditions. Example, if a pedestrian walk is detected across unexpectedly, the system will issue an alert. So the system will issue an alert to the braking control system and apply an emergency brake. So this is the simulation of ADAS. So SIVIC means simulation of virtual infrastructure and sensors. So this virtual sensors will give the input to the processing unit, as I said earlier, and this processing unit will work accordingly. So here we use the radar, camera, odometer, speedometer, and this will record the files. These files will be sent to the converters. After that, the converters will send to the whole processing unit. Before I mentioned the block diagram of that ADAS. Now, advantages of ADAS. So enhanced safety, reduces the human errors and prevent accidents. Driver assistance, there will be no driver needed. It will be automatically easy to drive. Improved traffic flow. Adaptive cruise control and automated braking helps in smooth traffic movements. Fuel efficiency, optimized driving behavior leads to better fuel consumptions and pedestrian protections. The detection of potentials and prevents the collisions. Disadvantages. It is a high cost, so it is not easy to use. Advanced ADAS features increases the price of vehicle. So basically, the base price of the vehicles, which are manual vehicles, are same. But in case we used advanced driver assistance system, ADAS controls, the price of the vehicle may increase. Sensor limitations. Poor performance in extreme weather conditions. So the sensors might work or might not work. It is the greatest disadvantage in ADAS. So if the sensors fail, it may lead to the accident. So legal and ethical issues, data privacy concerns. So it collects so many data. So this data can be hacked or can be misused. So this is the disadvantage. Applications. There are so many applications. Passenger vehicles, commercial trucks, and autonomous vehicles. So ADAS is used so many places. So these applications are thank you.